Hey, how's it going? Let's talk about ratios, rates, and conversions. Rocking out. Okay, so a ratio compares two numbers by division. So as long as b is not 0, you can say a to b like this, a divided by b, or a to b like this with a colon, a to b, or you can just write a to b. Basically, for every a units of one quantity, you have b units of another quantity. You can also think about it as multiplication. If you have a ratio of the boys to girls in class as 2 to 1, then you have twice as many boys as girls. So 2 times the number of girls. A ratio that compares quantities in different units is called a rate. A rate with a denominator of 1 unit is called the unit rate. You can write ratios to find unit rates and compare quantities. You can also convert units and rates to solve problems. Here's a problem. Which store offers the best deal? $25 for 2 shirts, $45 for 4 shirts, or $30 for 3 shirts. We can write each price as a ratio. Store A is $25 for 2 shirts. If I want to make that a unit rate, I would divide the top and the bottom by 2. 2 shirts divided by 2 is 1 shirt. $25 divided by 2 is $12.50. For store B, it's $45 to 4 shirts. If I divide the bottom by 4, I get 1 shirt. So if I divide the top by 4, I get $11.25. Store C is $30 for 3 shirts. If I divide 3 shirts by 3, I get 1 shirt. If I divide $30 by 3, I get $10. That looks like it's the cheapest. Store C has the best deal because its unit rate is the lowest. So for got it, if store B lowers its price to $42 for 4 shirts, does the solution to problem 1 change? Well, let's make a ratio. $42 to 4 shirts. And then let's make it a unit ratio. Divide the bottom by 4 to get 1 shirt. Divide the top by 4 to get $10.50. Still not as good a deal as C. So the solution to problem 1 does not change. Okay, so if we want to convert units, like feet to inches, you can multiply by a conversion factor. A conversion factor is a ratio of equivalent measures. A conversion factor is always equal to 1, kind of like this. 1 foot is the same thing as 12 inches. Anytime you have a fraction with the same thing on top as you have on the bottom, that equals 1. Since 1 foot is the same as 12 inches, this equals 1. So if I was going to change, like, let's say 36 inches into feet or 7 feet into inches, what I would do is take my 36 inches and I would multiply by a conversion factor, but I want the denominator to cancel out my inches. If I have inches here, this is like inches over 1. So if inches is on the top here, I need inches on the bottom here. 12 inches to 1 foot, so that when I multiply, inches over inches cancels out, and that's 36 over 12 feet. 36 divided by 12 is 3, so that's 3 feet. If I was changing feet into inches, so I'm starting with 7 feet, I want feet in the denominator so that the feet will cancel out. So 1 foot for 12 inches. The feet will cancel out, and 7 times 12 is 84 inches. So that's how you use a conversion factor. So you can log in to PowerSchool and open up your e-text and go to page 814, or you can look right here and, I don't know, take a picture on your phone or take a screenshot and save it to your favorite folder. But go ahead and do that, and then here's some more glorious charts. So that's useful information that you're going to be responsible for. If I ask you to change inches into centimeters, you're going to have to look that up. I'm not always going to give that to you. By the way, secret code phrase, twinklefish. That's right, twinklefish. Alright, so let's convert some units. What's the given amount converted to the given units? Okay, so 330 minutes into hours. So what's my conversion factor? It is 1 hour over 60 minutes, because that's going to make my minutes cancel out. So that means I need to do 330 times 1 divided by 60. So that's 330 times 1 is just going to be 330. Divided by 60 is 5.5. So 5.5, and the units that are left are hours. 15 kilograms into grams. 1,000 grams equals 1 kilogram. And I want to make sure my kilograms is on the bottom so that the kilograms will cancel out. And then I just do 15 times 1,000, and that's 15,000 grams. 5 feet and 3 inches into just inches. Well, I can separate my 5 feet and 3 inches into 5 feet plus 3 inches. And then I need to change the 5 feet into inches. So my conversion factor will be 12 inches over 1 foot, so that my feet will cancel. That's what happens when I try to dance. My feet cancel each other and I fall down. And then 5 times 12 is 60 inches, plus 3 inches is 63 inches. So, pause and see if you got it. And push play when you're ready to find out if you really did got it. Alright, well, we know that 100 centimeters equals 1 meter. If we've got 1,250 centimeters, I want to multiply by a conversion factor that has centimeters in the denominator. So that's going to be 100 centimeters to 1 meter. And then my centimeters will cancel. And I'm doing 1,250 times 1 divided by 100. When I divide by 100, it just moves my decimal place back twice. So that's 12.5 meters. So you notice that the units in the quantity are included in the calculations. That helps us know whether we're doing whether we're multiplying by 1 foot over 12 inches, which means we're really dividing by 12, or if we're multiplying by 12 inches over 1 foot. The units helped us set up the math. This is called unit analysis or dimensional analysis. So you have to include your units in your calculations. Alright, so let's do another one. The CN Tower in Toronto, Canada is about 1,815 feet tall. About how many meters tall is the tower? Use the fact that 1 meter is approximately equal to 3.28 foots. So, we're going to use this to make a conversion factor. So, what do you want on the bottom? Meters or feet? That's correct. We're starting with feet, so we want feet on the bottom so that the feet will cancel. So 1,815 feet times 1 meter over 3.28 feet equals, I guess we should probably use squiggly equals here since this is approximately equal to 1. Remember, because 1 meter is approximately equal to 3.28. So this should be approximately equal to, let's see, and then we do 1,815 divided by 3.28, and you get, let's see what that looks like on Mr. Calculator here, so we know how they're rounding. 1,815 divided by 3.28 is 553.35, and they just round to the nearest meter. Did they tell us to round to the nearest meter? No, they just said about how many meters. So 553. It's pretty good. So here's one way to check. Round You remember like estimating that you used to do? 1815 to 1800, 328 to 3. Then you divide 1800 by 3, and that's about 600, which is pretty close. So that sounds like a pretty reasonable answer. All right, let's see if you got it. Pause it and see if you got it. Okay, so we know a building is 1,450 feet tall. We want to find out how many meters it is. So we're going to multiply by a conversion factor that has feet in the bottom and meters on top. 1 meter is approximately equal to 3.28 feet. Our feet will cancel, and we're going to get 1,450 divided by 3.28 is 442, approximately. 442 feet. All right, B. We're starting with $325. So 325, you can write it like this if you want, dollars, times, we want to get our conversion rate with dollars on the bottom. $1 is equal to 0.63 euros. Now our dollars will cancel, and we just need to do 325 times 0.63, and that's 204.75. So that's 204.75 euros. Our dollars canceled out, and our units are euros. All right, a student ran a 50-yard dash in 5.8 seconds. 50 yards. What speed did the student run in miles per hour? Now they tell us to round to the nearest tenth. All right, so what do we know? We know the running speed in yards per second. 50 yards per 5.8 seconds. We need the running speed in miles per hour. So let's write the speed as a ratio and then choose some conversion factors. All right, so 50 yards per 5.8 seconds. I know that 1 mile is 1,760 yards. So my yards will cancel, and then I'll have it in miles. And I know that there are 3,600 seconds in an hour, and that will make my seconds cancel. So what I really end up doing is get in my calculator, and now I start with what's on top, 50, divide by anything that's on the bottom. So divided by 5.8, and then times 1, and then divide by 1,760. And then multiply by 3,600. And I get 17.6, which sounds really fast for a person to be running. I don't really know if a person can run that fast. What do you know? Do you know? Do you know? Do you know? So what they did is they just multiplied everything that was on top, got 180,000, multiplied everything that was on the bottom, and then they did 180,000 divided by 10,208 and got the same thing that we got by just typing everything in. So that is a really fast student, in my opinion. I don't think I could run 17 miles an hour. That's fast. So pause and see if you got it. All right, so our sprinter ran 100 feet in 3.1 seconds. So that's feet per second. And now I want to get miles per hour. I know that 1 mile equals 5,280 feet. And I want my feet to cancel. So I'm going to put my feet on the bottom because these feet are on top. So 5,280, 1 mile. And I want to cancel seconds. So I'm going to put seconds on top and hours on the bottom. And if you look right up here, there's 3,600 seconds in 1 hour. And just for funsies, let's do like they did. Let's see, our feet are going to cancel. Our seconds are going to cancel. And we'll be left with miles per hour. And 100 times 3,600 is 3,600 with 2 more zeros on it. So that's 360,000. And then 3.1 times, what was it? This guy got out of my way. 5,280. 3.1 times 5,280 is 16,368. 16,368. And then I can just divide those. So I just need to do 360,000 miles divided by 16,368 hours. I had to write it up there because my calculator is going to make my bottom of my screen go away. So 36,000 divided by 16,368. Holy cow. 21.99. So that's approximately 22 miles an hour. Was that it? 22 miles per hour. Man, that is so fast. It's like faster than my scooter. Alright. See you later. Catch you on the flip-flop. Bye.